Hi everyone, today I'm going to show you about the 3D visualization of Bertrand paradox. So let me build this first. And so here you can see the three sphere and the tetrahedron that is drawn inside the sphere. So so the first sphere the first sphere is this sphere is for the random endpoint, and the middle one is for the random radius, and the right one is for the random midpoint. So this whole sphere is of the same size, and the tetrahedron is also the same shape. So before starting this one, there are two types of chord that is being drawn, the red one and the yellow one. If the chord length is greater than the side of a tetrahedron, then the color is red, and if the chord is less than the side of the tetrahedron, then it's yellow. So in this control, you can see the number of chord for the whole method, and the default one is 1500. So I will just do it for like 10,000 so that we can clearly visualize how it looks for the each of the method. And this one is for the probability. So the first one is the probability for random endpoint, the probability for random radius, and probability for random midpoint. So let's run all the method at once. So you can see the red one is the chord that is longer than the length of the tetrahedron side, and the yellow one is the shorter one. You can see the probability where, and this one is the number of chord that has been drawn, and this one is the number of the long chord. So that's how the probability is being calculated. It may take some time because we are drawing 10,000 of chord. So you can see this in this part, the red one, the center of the paradox is being red for the random radius. Okay, let's go inside the sphere how it looks like. So this one is for the random radius. So you can see in the center of the sphere. So this one is the center of the sphere. It's fully red in the center of the sphere for the random radius. So you can see the difference over here. So the center of the sphere is fully red. You can see. And let's go to the random endpoint. So for the random endpoint also, the center is like the red one, reddish one, but there is some of the code that is yellow for in the center also. So you can see this one. So there is some of the code that is being yellow in the center also. But so it's the mixture of yellow and red, but the majority of the code is red in the random endpoint also, just like the random radius. So you can see this one. Let's move to the random midpoint. Now let's move to the random midpoint. So in the random midpoint, there is some mixture in. So we cannot say which one is mostly dense because you can see the red one and blue one, the red one and the yellow one, but the majority of code is yellow in this case. So you can see it's the mixture of red and yellow. So yeah, that's my Bertrand paradox, and you can see the probability of it's like 1 by third for the random endpoint and 1 by 2 for the random radius, and 21% is like 1 by fourth for the random midpoint. So, so this is this is the pattern important paradox. So this is the final lookup as result after running all the codes. So I just want to show you this one. So you can see for this one is pretty red, and for this one, so for this one is the probability is like 50%. So you can see the red code mostly in this case, and for this one the probability is like 1/3%, so 1/3. So you can see there is some reddish part over here also. For this one, the probability is like 1 by 4th, so you can see most part is yellow. So yeah, that's the result for all of this. Thank you.